So for the next problems, we're going to complete these steps. We're going to find the domain, write it in lowest terms, find the x and y intercepts, test for symmetry, find the vertical asymptotes, find the horizontal and oblique asymptote, and then graph it. And we can do all these things, so we're just putting it all together. The key thing here is when we write it in lowest terms, if a factor crosses out, it is a hole in the graph at that point, not a vertical asymptote. So let's try some problems. So here we go. We have this problem right here. So find the domain. So to find the domain, we look at the denominator. Pause the video, see if you can do the domain on your own. You should say that the domain is negative infinity to negative 2. No. Yes. And negative 2, 2, 2, and then 2, 2, infinity. So you should say that. Alright. Write in lowest terms. If a factor crosses out, there's a hole in the graph. So let's factor the top. The top factors x squared minus 1 to x plus 1 and x minus 1. The bottom factors to x squared plus 4 and x squared minus 4. Well, x squared minus 4 also breaks to x plus 2x minus 2. That's how I got the domain. So, is anything the exact same on top that's the exact same on bottom? Nope. So it's already in lowest terms. So we're going to find the x and y intercepts. To find the x-intercepts, we plug in 0 for y. Some of us have been struggling with this. So if we plug in 0 for y, we are going to cross multiply and get 0 equals just the top. Will that always happen when you set it equal to 0? Yes, the denominator will go away. So solve for x. So set each part equal to 0. So this right here would give you x equals 1 and x equals negative 1. So we're going to go 1, 0 and negative 1, 0. Notice I wrote them as an ordered pair. Crazy! Alright, to find your y-intercept, we are going to put in 0 for x. So we got y equals 4 times 0 squared minus 1 over 0 to the 4th minus 16. So on top you have negative 4, on bottom you have negative 16, so that reduces to 1/4. So 0, 1/4 is your y-intercept. Now we're going to test for symmetry. To test for symmetry, you plug in negative y and negative x. So I plug in negative y for x-axis symmetry. It will not reduce because I have negative y equals all this jazz over here. And if I multiply by negative 1, it would not work, so sad face. So for y-axis, we are going to put in negative x. When I put in a negative x and square it, it still becomes x squared. When I put in a negative x and take it to the 4th, it still becomes positive x to the 4th. So if you notice, this is the exact same. So yes, it has y-axis symmetry. Since it didn't have x-axis and it does have y-axis, it will not have origin. Origin is a sad face as well. So y-axis is our answer. Alright, from there we need to find the vertical asymptotes. We can find those by looking at our denominator. What makes it 0? You should say your vertical asymptotes are x equals 2 and x equals negative 2. Notice I put x equals. If you don't, I will count it wrong. Find the horizontal or oblique. So to do that, we must divide. So on top we have 4x squared minus 4, and we're going to divide it by x to the 4th minus 16. Well, you should see that you can't do division because we have squared over 4th, and you can't do that. So you would get y equals 0 as a horizontal asymptote. So we're going to graph. So if we graph this, we are going to plot our intercepts. So we have an intercept at 1, 0 and negative 1, 0. We have an intercept here at 0 and a 4th. And then we have a vertical asymptote at x equals 2 and x equals negative 2. We also have a horizontal asymptote on our axis. But so you say, well, we have points here, so how can we have a vertical asymptote or horizontal asymptote? Well, Asymptotes are the ends, what's going on at the end of your graph. And that means at the end of our graph, we do have one. In the middle, we don't. So we're going to connect these 3 dots in the middle here and make a lovely parabola. We need to figure out where our L's are going to be, if they're going to be up here or down here or up here or down there. So I'm going to put in a number on the other side of 2, negative 2. So if I put in another number on the other side of negative 2, like negative 3, if I type that into my equation, put it into my equation, I would get, if I put in 3, positive half. So I'm going to go over 3 and up a half. Notice it is over on the top, so I'm going to make an L up there. All you have to do is find one point. If I put in 3, I also get positive half, and so it's also going to be up in the top. And there you go. There's your graph. So let's do one more. So, find the domain. To find the domain, we must factor the bottom, because we've got to look at the bottom. So the bottom factors x plus 3, x plus 5. You could have done that by tic-tac-toe or by an area model. So that tells us that our domain is negative infinity to negative 5, because negative 5 from that one. Then negative 5 to negative 3, because negative 3 for that one. Then negative 3 to infinity. Right in lowest terms. So the bottom's factored, factor the top. The top would factor to x minus 2 and x plus 5. So does anything cancel out? You should say, yay, it does. So our lowest terms is going to be x minus 2 over x plus 3. So since something canceled out, that means you have a hole at that x value. So the x plus 5's cancel. So this makes a hole at x equals negative 5. If we plug in negative 5 to our original equation, you would get undefined. However, if you plug in negative 5 to this equation, you will not get undefined. You will get negative 7 over negative 2, which is positive 3.5. So we're going to have a hole at negative 5 and 3.5. Yay, go you. Alright, so now we're going to do all the other stuff, just like we did on the last one. Find the x-intercept. So put 0 in for y. So if I put 0 in for y, that means I'm going to multiply by my denominator. And instead of using the big long version, I'm going to go ahead and use the simplified version because we'll get the same answer. So I'm going to cross multiply by my denominator, and so I get 0 equals x minus 2. So I would have an x-intercept at 2, 0. Put in 0 for x. So I got y equals 0 minus 2 over 0 plus 3. So I get 0 and negative 2/3. And that is my y-intercept. To test for symmetry, we put in negative y. That will help us for x-axis. And when we put in negative y, and I'm going to go ahead and use my simplified version, which works still. I put in negative y. If I multiply by negative 1, it's still not going to help. So sad face. For y-axis symmetry, I put in negative x. So I get negative x minus 2 over negative x plus 3. If I multiply by negative 1, that's still not going to help. So sad face. If I put for origin, negative y and negative x minus 2 over negative x plus 3. That's not going to help because it's going to change some of these symbols on the 2 and the 3. So that's still not work. So sad face there. So no symmetry. Vertical asymptotes we find from our denominator. We've already said that one is a hole, so it can't be an asymptote too. So this one at x equals negative 3 is our vertical asymptote. Notice they're both included. One is a hole and one is a vertical asymptote. For horizontal or oblique, we must do long division. So we have x squared plus 3x minus 10, all divided by x squared plus 8x plus 15. And when you divide x squared by x squared, you get 1. So we got x squared plus 8x plus 15. When you subtract, you get negative 5x minus 25. and you cannot divide. So we get y equals 1 is a horizontal asymptote. No oblique asymptote. So let's graph it. So we plot our intercepts. 1 at x equals 2, 0, and 1 at 0 and negative 2/3. Alright. Then we're going to plot that hole at negative 5 and 3.5. Notice it is an open circle right there because it's a hole. Alright, from there we got our vertical asymptote at negative 3, x equals. We have a horizontal asymptote at y equals 1. So that we have points in both sides, so we have our L's. So our L is going to be down here if we connect those dots. And for the hole, we're just going to extend a line from it that gets closer to those asymptotes. And you're done. Yay, go you. If you have questions over this, come with them for next time.